One of the main uses of numerical methods is for finding approximate solutions to equations. We usually write our equation in the form f of x equals 0, so that when we sketch y equals f of x, any roots will be where the graph crosses the x-axis. By far the most important tool at our disposal is the sign change test. The sign change test can be used to tell us that there's a root in a particular interval. Suppose we know that f of 1 is positive and f of 2 is negative. Must there be a root between 1 and 2? Pause the video and decide for yourself. Pink Mouse doesn't know the exact shape of the graph, but she thinks there has to be a root somewhere between 1 and 2. Blue Mouse disagrees because the graph could look like this. Purple Mouse also disagrees with Pink Mouse. She says that there could be an asymptote like this, so again, there needn't be a root between 1 and 2. That's good thinking, Pink Mouse, but Purple Mouse is right. You can only be sure of a root if the function is continuous on that interval. But what are you doing, Blue Mouse? Your graph isn't even a function. Look, one value of x has two values of y. So, the sign change test says that if a function goes from positive to negative between two values of x, or from negative to positive, and if it's continuous between those numbers, so there's no asymptote or anything like that, then there must be a root somewhere in that interval. How do you get the marks? Well, there are some very specific things you need to write. Suppose we're trying to prove that there's a root between x equals 1 and x equals 2. The first thing is to work out the value of the function at these points. Always write down at least 3 significant figures. That one's positive. I'm making these numbers up, by the way. And that one's negative. Now you have to finish with this very precise sentence. We're saying that since the function is continuous on our interval, the change of sign guarantees a root in that interval. Your work will always look exactly like this.